Hello. Check for mic. Hello. Hello. Okay. This working fine. We can start now. Hello students. In the last class we have discussed integration, both indefinite as well as definite integrals. In this session we will take the new chapter, that is applications of integrals. We already know what is the application of integral by using definite integral. We have already discussed what is a definite integral and how to evaluate definite integrals. We will use the definite integrals to find applications of integrals. How do we apply? What is the application of integral? It is finding areas between curves, either between lines or different curves. We can find area between a region by using integrals. We will discuss that how to find the areas of different types of curves in this session. Okay, let's start. So the chapter is applications of integrals, that is nothing but finding areas under curves. Okay. First is how to identify areas. Mainly questions will be asked. In the wording will be area bounded by the curve and some value, or area bounded between two curves. Questions will be asked like that. Then we have to understand what is the meaning of bounded. Bounded means it is a closed figure. That is the meaning of it. Area of bounded regions. Always we can calculate the area when it is bounded. When the curve is bounded between different lines or another curve. That means the entire shape will form a closed figure. That is the meaning of it. Bounded means closed shape. Okay. Now the first case is, suppose f of x is this curve, that is y. We want to find the area between two points, that is x equal to a and x equal to b. Now how to find the area? We already know what is a definite integral. We have discussed. Definite integral is nothing but, we will take some strip here dx and we will move that strip along from a to b, and that will give us the total net area. Here what we will get? We will use the same procedure. We will take a strip and move that strip along. We will take a strip. Let this strip be dx. Dx is the width of this strip and the height is, length is this y value. And what we will do? We will move the strip along from A to B. That means we will get the entire length of this region and the height will be y values. So what we will do is, assume this dx is very small number. That means this difference between the first line and the second line in the strip will be negligible. That means we will consider this distance as, this is a rectangular strip. When we assume this as a rectangular strip and add all the y values, that will give us the entire area of the region. That is the way of calculating. That is the approach we use for finding area between curves. So here the area bounded between region, the curve is there and the lines are x equal to a and x equal to b. Within this interval we have to find the area of the curve. That is the meaning. Okay. Now what we will do? We will move this strip along A to B and this entire region, add all the y values. That will give us the area. As y is positive, we can directly write this is nothing but integral of from A to B y dx. That is it, or f of x dx. Let's see that. So we have to calculate this entire area, that is given by area of the region bounded by the curve y equal to f of x, y is equal to f of x, and x-axis y equal to f of x is the curve and x-axis and the lines x equal to a and x equal to b, and the ordinates x equal to a and x equal to b. So we have to find this area. As this y value is always positive, that is f of x is always positive, we can find the area enclosed between this interval as nothing but integral of, from a to b we are adding the y value. We already know what is definite integral. It is nothing but the summation. So we will get integral a to b f of x dx. Second case, if y values are all negative, if all the y values are negative, we can consider a similar case just like how we did in first case. Here we will get the strip again from a to b. We have to calculate this area between a to b, x equal to a and x equal to b, but the y values are negative. That means when we add all the negative values, answer should be negative. So when we calculate definite integral, answer will be negative. But we know that area is always positive. So what we need to do? Take modulus. The net area will be same as all the y values here are negative, but area cannot be negative. So that's why we will take modulus for this. Or just calculate the area just like in the previous case between a to b. So we can write integral between a to b f of x dx or y dx, and the answer will be negative. So take the modulus. So here y equal to f of x, x-axis, and lines are x equal to a and x equal to b. Again, this is a bounded region as this shape is closed shape. Okay, so integral will be, this is a negative value. So when we take modulus, it will be minus of integral a to b f of x dx. Or we can write modulus as f of x is all negative. Next is, if the curve is like this, curve is defined by x equal to f of y. That means what we are going to do is, we are going to move the strip along y-axis. In the previous case, we moved the strip along x-axis. Here we will move the strip along y-axis. So that means strip will be like this, horizontal strip. We will move along vertical direction, that is y-axis. This is dy. Now we will move this strip from a to b along y-axis. As x values are all positive, now what we will do? We have to integrate. This curve is given by f of y and the strip is dy. That means we have to write this integral, the function integrand, as a function of y, as the strip is moving along dy. That means variable of integration will be y dy. So that means we have to write this function in terms of y. That is why we are giving x equal to f of y. That means first we have to find the value of x. If the curve is something, then after that we have to integrate. That means we will get integral of between a to b x dy or f of y dy. That will be the answer for this case. Now we will see. We have to calculate the area bounded between y-axis and y equal to a and y equal to b, and the curve is x equal to f of y. So lines are y equal to a and y equal to b. Now what will be the area? Area is equal to integral of between a to b f of y dy, or we can write it as x dy. It will be easy to remember when we write it like that. Integral y dx or x dy. Change the variable. For dx means we have to write y, and for dy we have to write x. So this will be integral a to b x dy or f of y dy. The next case is similar to the previous one. Here this value is, all the x values are negative. So that means answer will be minus of x. So when we add all the x values which are negative, lines are y equal to a and y equal to b, and the region bounded between y-axis, these two lines, and the curve. Again, this will be, as the x values are negative, answer will be minus of some value, and this area will be positive always. So we'll take the modulus for this. Procedure is same as previous. So area bounded between the curve x equal to f of y and the lines y equal to a and y equal to b. So that is given by this area, which is equal to minus of f of y dy, as this f of y values are all negative, but area should be positive. Or we can write it as modulus of this value. Modulus of integral between a to b f of y dy or x dy. Next case is, let f of y equal to f of x is a continuous function on the interval, and the curve is given by, we have two regions, where one region is positive, another region is negative. Can you tell the answer now? It is very easy. Just how we did in the previous 4 cases, we will apply the same logic here. But here we already know how to evaluate definite integrals and its properties. Integral into two separate integrals. We will find the limit between a and c, and then c to b. Then we can evaluate these two integrals separately. We can find these two integrals separately. So what we will get? Between a to c, y values are positive, and between c to b, y values are negative. And the curve is bounded between x-axis and x equal to a and x equal to b. And y values are positive in some region and negative in some region. When we calculate definite integral value, it will give us the net area, because this region will be added and the area of this region will be subtracted. If this is a1 and this is a2, when we calculate definite integral, answer will be a1 minus a2. But as we are calculating only area, it should be both positive. So we will add a1 plus this area is a2, that is modulus. We have to take modulus. So add both. That is why, as the curve definition is changing here for finding area, we are taking into two separate intervals. So the area of the region bounded between the curve f of x-axis and the lines x equal to a and x equal to b is given by, we have to take two separate integrals. That is between a to c, y value is positive. So between integral a to c, f of x dx, then we will take modulus for this region, modulus of integral between c to b, f of x dx. Next case is, now the curve is bounded with y-axis. So again lines are y equal to a and y equal to b. Now we should find this area. Just like in the cases 3 and 4, we will use the same logic. Now this area is x value is positive in this region and x is negative in this region, and the strip is moving along dy. Whenever we have to remember that when we move strip along dy, we have to think of x values. Here x is after 0, it will be positive region, so this is positive. Here it will be negative. So that means we will take this area as it is and take the modulus for this interval. So again, what will be the answer? Can you guess? It will be area is equal to integral y equal to a to c x dy, that is f of y dy, plus modulus of integral c to b x dy, that is f of y dy. So what is the answer here? It is same as the procedure. Whenever we can draw the curve correctly, we can find the area easily. And in this chapter, area will be very easy to find. Integration will be very easy. You just need to know how to integrate standard functions. That will be enough. So you can solve more than 90% of the question with just that knowledge. So here we get y equal to a and y equal to b. Integration between a to b, and the curve is changing its sign is changing here at the point C. So we will find the area as integral between a to b, a to c, x dy, that is f of y dy, plus modulus of between c to b, x dy, that is f of y dy. Until now we have seen area bounded between a curve and lines, that is x-axis or y-axis between any two intervals, x equal to a and b or y equal to a and b. Now what we will discuss is area of the region bounded by two curves. Bounded by two curves or bounded between two curves, both are same. Suppose the curve y equal to f of x is like this, and the another curve is y equal to g of x. So the top curve is y equal to f of x and the bottom curve is y equal to g of x. Interval is between a to b, where a and b are further away points. We have to find the area bounded between the curves. Whenever we have to find area bounded between the curves, first understand this interval does not matter. We only need to know this region. Other than that, it is not there. This curve is not there. So area bounded between the curves meaning is area enclosed between the two curves. That means bounded means it is a closed figure. So first we need to know at what points these two figures are enclosed. That will give us the point of intersection first. When you know the point of intersection, we can find the points between which the curves are enclosed. So first we have to find the points of intersection for such cases. Then what we need to do? Find f of x, that will be addition of all the y values, and integral g of x will be again addition of g of x curve y values. So the net result is, if you are taking a straight line, we have to find this y1. Let's take f of x value as y1 and g of x as y2. F of x as y1 and g of x as y2. Then we will get y1, that is this region, minus y2 will give us the area, the region, the line enclosed between these two curves. That means when we add all these values, f of x minus g of x, we will get the area between the curves. And what is the interval between the points of intersection? That is how we should solve this. So first we have to find these 2 points, that is the points of intersection. And for finding points of intersection, as we are moving the strip along x-axis, that is strip will be dx. That means we have to find the dx means x coordinates will be required. Just like how we seen in the previous case, x equal to a and x equal to b are the two limits within which we are moving the strip. So here similarly, when we have to find the point of intersection, we don't need to calculate both x and y values. We just need to know the x coordinate, that is x equal to x1 and x2. Then we can move the strip in dx direction along x1 and x2, that is between x1 and x2 will be integral x1 to x2 f of x minus g of x dx, that is it. And this is applicable only when the functions, both the functions are continuous. And let these two be continuous functions such that they intersect at x1 and x2. And where x1 and x2 both lie within the interval. And x1 is less than x2. Then what will be the integral? If f of x is greater than g of x, that is f of x curve is lying above g of x, then we can find the integral as area is given by integral between x1 to x2. F of x is higher value and g of x is lower value. So we have to subtract this. F of x minus g of x will give us the net area result, and we have to add all the dx values. That is, we have to move the strip from x1 to x2. So this is x1 to x2 integral upper curve minus lower curve. That is f of x minus g of x dx. Next is, the curve is looking like this. Any arbitrary curve, y equal to f of x and y equal to g of x. where this point is A and B, and in between there is a point of intersection. Now how to find the area? Can you guess this now? This curve is g of x and this curve is f of x. Procedure is same, but there is a point of intersection in between. Then what we will do? Again, follow the same procedure as previous case, but the curve nature sign changes here. So we will split the interval here also. Then what we will do? Find between A to C what is the value, and between C to B what is the value of area, and then add both these regions. So here what will be the answer? This curve is f of x and this is g of x. That means integral will be between A to C f of x minus g of x, and between C to B g of x is greater than f of x. That means integral will be between C to B g of x minus f of x. That is it. So that is how we should find this. Y equal to f of x and g of x are two continuous functions, and we know the region between which we have to find the area, that is between A and B, and there is a point of intersection in C. Then we will get area is equal to integral A to C between this region A to C f of x minus g of x, as f of x is the higher curve, and between C to B g of x is the upper curve. So we will write between C to B it is g of x minus f of x. Next, area bounded between the curves where the curves are non-intersecting. The previous two cases is where curve is intersecting. Now the curves are non-intersecting. That means this is f of x and g of x. Then we will know between which two interval, between which two points we have to find the value of the area. Let's take this as x equal to A and x equal to B. We have to find the area between these two regions. So that means again the value is same as previous case. Can you guess easily? It is nothing but again f of x minus g of x. Limit is between A to B. Just add all the y values, y dx. That is it. So again y equal to f of x and y equal to g of x, where the two curves are non-intersecting now, but then we will have the interval between which we have to find the area. That will be given. And remember, we can find the area only when the curve is bounded. If it is non-bounded, it will go to infinity. That means we can't find the area. It is undefined. So we will only find the area between the curves when the curves are bounded, or if you have area of the curve means they will give the region with which it will be bounded, or area between the curves means those two curves will be either intersecting or we will have an interval between which we have to find the area. So the overall approach is we have to have a bounded region within which we will find the area. Okay. Now this is x equal to A and x equal to B. So again upper curve minus lower curve, that is f of x minus g of x dx. Integral is between A to B. Next is find the area bounded between the parabola and the x-axis and the lines x equal to 1 and x equal to 2. Now we will solve some problems for areas. We will discuss all types of problems and solve. Okay. The first thing we should know is how to draw the graphs of different functions for finding area. That is the very crucial step. And always remember, we can draw the graph Remember two key points while drawing graph. First one is, if you have x square term, when the term is even for x, which means graph will be symmetrical about or even powers of x. Even powers of x in the function. Then we will get even powers of x means graph will be symmetrical about, graph is symmetrical about y-axis. when you have y equal to x square, for example is y equal to x square. Y equal to x square graph is like this, and this graph is symmetrical about y-axis. Obvious, but from y-axis both this region looks similar. It is just a mirror image on the other side. So that means we can write, when we have even powers of x, that is x square, x power 4, x power 6, only those terms exist in the function, means the graph will always be symmetrical about y-axis. Similarly, when we have even powers of y, that is y square terms, then we will get graph will be symmetrical about x-axis. That is it. And the next is, for example, y square equal to x, y square equal to 4x. Then what will be the graph? Y square equal to x is a parabola which is open, right one. We already know this. Again, this graph is symmetrical about x-axis. You have to remember these key points. Next is, if the graph is, suppose we have both even powers for x as well as y, then the graph will be symmetrical about both the axes. Even powers for both x and y. That means graph is symmetrical about both axes. Can you tell one example? Easy. We can take example as, say, x square plus y square equal to 4. Circle. It is symmetrical about both the axes. Yes, it is symmetrical about y as well as x axis. So what is the understanding? When you have these three cases, you have to remember this. When you have x square term, graph will be symmetrical about y axis. Y square power means we have to take x axis symmetry, and if there is both even x and y are of even powers, then graph will be symmetrical about both the axes. Other than these points, you have to know basic knowledge of how to draw lines. Suppose x equal to 5, then how to draw these lines. Y equal to 2x plus 1, how to draw the line of that. And then know the basic shapes like parabolas. Y square equal to 4ax, y square equal to minus 4ax, x square equal to 4ay, x square equal to minus 4ay. You should remember these parabolas, how to draw the graph of parabolas. Other than that, ellipse and circle. These are the major diagrams or graphs which you will be very comfortable with for drawing. After that, we can easily solve the problems. Okay, this is the basic of how to draw the graphs. Now we will see the problems. Here, find the area bounded between the parabola, that is y equal to x square, and the x-axis, and the lines x equal to minus 1 and x equal to 2. Okay. Find the area bounded between the parabola y equal to x square and the lines x-axis and x equal to minus 1 and x equal to 2. The first step we should do is draw the graph of this. Y equal to x square, x equal to minus 1 and 2. Y equal to x square, x equal to minus 1 and x equal to 2. Now how to draw the graph of this? Y equal to x square graph is parabola, and x equal to minus 1 line will be here and x equal to 2 line is here. Now what do we need to find? Area bounded between x equal to minus 1 and 2 and the parabola, that is this region and x-axis. So we should find this area. Is that clear? First step is to draw the graph of this and then identify which area is bounded, for which we have to calculate the graph. So here graph is between y equal to x square and x equal to minus 1 and 2. That means we have to find the shaded area. Now how to find this area? We already know the limits between minus 1 to 2 and y value is always positive. That means we can directly write area as area is equal to integral of between minus 1 to 2, between minus 1 to 2 and y dx, y dx, y dx. As the strip is moving along x-axis, we are taking the strip, vertical strip moves along x-axis. So this is nothing but integral of minus 1 to 2. When we write y, we have to write the y value. Y is equal to what is the function? That is how we should write. So here x square dx, that is equal to, what is the integration of x square? We already know how to calculate integration, indefinite as well as definite integration. This is the definite integral. Why do we use definite integral for finding? Because again, when we shift this entire curve to the right hand side or up or below, this curve value area between this region will remain same. That means irrespective of whatever constant is there, area will remain same. So it is naturally a definite integral for finding areas. So that means we will get the integration of x square is x cube by 3 between the limits minus 1 to 2. Now what is the value for this? This is equal to, substitute the values. Upper limit is 8 by 3, 2 cube is 8, minus of lower limit will be minus 1 by 3, minus 1 cube, that is minus 1 divided by 3. So this minus will become plus. We have 8 plus 1, 9 by 3, 9 by 3, that is equal to 3 square units. 3 square units. That is it. So value of area bounded between this is 3 square units. Now we will see the solution for this. First we have to draw the graph bounded between minus 1 to 2, and as the y values are always positive, we will take this between minus 1 to 2 y dx, that is y is x square here. So required area is area between minus 1 to 2 x square dx, that is x cube by 3. The thing we have to remember all the time is, see, if the strip is moving along the horizontal direction, that means we are adding the y values. So it is y dx. It will be easy to remember. Why do we keep repeating this? When we write y dx, that means we have to write the function as y, that is y is equal to function of x. That is the meaning of f of x here. Right now, 3, 9 by 3, that is 3 square units. Next question is, find the area enclosed between the curve y is equal to x cube plus 3 and x equal to minus 1 and 2. Okay, this is again similar to the previous question, only curve is different. Now how to find the area of this? Y is equal to x cube plus 3. So what is the graph of y equal to x cube plus 3? We can draw here. Wait, I will change the color. We can take red. Y is equal to x cube. Y equal to x cube graph is like this. When we add 3, then this entire graph will shift 3 units above. So y equal to x cube graph will be like this. And the region is between minus 1 to 2. When x equal to minus 1, it will be minus 1 plus 3, so positive value. So that means this is x equal to minus 1 and x equal to 2 will be here. Okay, now what we need to find? Area enclosed between these two values, x equal to minus 1, x equal to 2 and y equal to this. and the x-axis. Between the curve means we have to take the x-axis as the limit. So we have to find this area. Again, what is the area? We can directly write area is equal to integral of, as the y values are always positive, we can write the without splitting, that is without splitting the intervals, we can write between -1 to 2 integral of y dx. And what is y here? Between -1 to 2, y value is x cube plus 3 dx. X cube plus 3 dx. That is equal to, what is the integration of this? X power 4 by 4 plus 3x, and the limit is between -1 to 2. Now apply the limits. Easy. So what will get? 2 power 4, 16 by 4 is 4, plus 3 into 2, 6, minus of, then we will have -1 power 4, that is 1 by 4. Again we will have -3. That is it. So this is equal to 4 plus 6 is 10, minus 1 by 4 plus 3, that will be plus 3 minus 1 by 4, that is 13 minus 1 by 4, which is equal to 13 into 4 is 52, minus 1, 51 divided by 4. 51 by 4 square units. So what is the answer, students? Area is equal to 51 by 4 square units. So this is how we should find the area. Now we'll see the solution. Curve is x cube plus 3 and the interval is between -1 to 2. So required area will be between -1 to 2. As the y values are positive, we can directly write and add the values. So this is between -1 to 2 f of x dx, and here also x cube plus 3 dx. So just integrate and substitute the limits. So answer is 51 by 4 square units. Next question is, find the area cut off between y equal to 0 and y equal to x square minus 4x plus 3. Okay, cut off between means again it is bounded area only. First we have to draw the graph. That will be now y equal to 0 is this line, y equal to 0 is this line, and then y equal to x square minus 4x plus 3, x square minus 4x plus 3. Now what are the factors for this? Factors are x minus 1 into x minus 3. We can write this as x minus 1 into x minus 3. How to draw the graph of this? When x equal to 1 and 3, y value will become 0. So at 1 and 3, y value will become 0. After 3, it will be positive. Less than 1, it will be positive. Between 1 to 3, suppose 2. 2 minus 1 is positive, 2 minus 3 is negative. That means answer will be negative always. So the rough graph is something like this. Rough graph will be something like this. Now what we need to do? Find the area of this. That means area enclosed cut off between y equal to 0. Y equal to 0 line is x-axis. Area enclosed between y equal to 0 and then y equal to this curve, x square minus 4x plus 3. So the curve is this one. This is the region cut off. That will be this region, the shaded region. Okay. Now that means how to find the value of area? Area is given by, area is equal to integral of between 1 to 3, limit is between 1 to 3, y values are negative here, so we have to write minus of y dy, y dx, or we can take the modulus finally. Area will be minus of x square minus 4x plus 3 dx. as we are adding all the y values. Here curve is already given in the form of y is equal to some function f of x. So this is equal to minus of, just integrate this, that will be x cube by 3 minus 4x square by 2, that is minus 2x square, minus 2x square, then we will get plus 3x, limit is between 1 to 3. Now substitute the values. Minus of 3 cube by 3, that is 9, minus of 3 square is 9 into 2, 18, plus 3 cube into 3, that will be 81, 3 power 4 is 81, minus of this value, minus of, we will get 1 by 3, minus 2 plus 3. This will be 4 by 3. We'll take this color. This value is 3 minus 2 is 1, 1 plus 1 by 3 is 4 by 3. So we have to subtract 4 by 3. This value will be minus 9, that will be 72. Minus 72 plus 4 by 3. So we can calculate this value after. We'll just see the solution. Right now, you can do this from here. So that means first we have to write this curve. Find the factors first, and when y equal to 0, what are the x values? That will be x minus 1 into x minus 3. So when x equal to 1 and 3, this value is 0. Y value is 0. And at other places, y value will be negative in between this region and positive in the other regions. First we have to understand and draw a rough graph. Then what we need to find? Required area will be between 1 to 3 minus of y dx, that is minus of this region into this curve into dx, minus of between 1 to 3 x square minus 4x plus 3 into dx. Then just integrate and substitute the limit. That comes out to be x cube by 3 is, that is 3 cube by 3, 3 square is 9, minus of, this will be 2 into x square is 9, that is 18, plus 3 into 3, that is 9, minus, again, okay, in the last step while we are calculating, I wrote this as 3 cube, that is a mistake. No, so it will be again procedure is same. So here 3 into 3, that is 9, minus of, substitute the lower limit, that is 1 by 3 minus 2 plus 3, and final answer comes out to be, this is 0, 9 plus 9 minus 18, that is 0, minus of, this value is 4 by 3. So it is minus of minus 4 by 3, that is 4 by 3. Next question is, find the area cut off between x equal to 0 and x equal to 4 minus y square. Find the area cut off between x equal to 0 and x equal to 4 minus y square. Again, we need to know the graph of this. How to draw the graph? X equal to 0 means it is y-axis. It is y-axis. And x equal to 4y square. That means we have to write this curve as y square equal to, first write in standard form. You can take y square to this side, then it will be 4 minus x. That can be written as minus of x minus 4. Now this is a parabola. What is the vertex? 4, 0. So vertex is 4, 0. And this is of the form y square equal to minus 4ax. That means parabola will be open leftward. So parabola will be leftward opening. And area cut off between x equal to 0, that means y-axis, and this region. So that means we have to find the area of this shaded portion. Now for finding this area, we can observe that this curve is actually symmetrical about x-axis, as we have y square term. Even powers of y exist in this curve. That means this curve is symmetrical about x-axis. That is one thing. Next, what we need to see, find the values of this region. And we can move the strip, either calculate from 0 to 4, move this region from x dy, or we can do y dx, or we can do the other. Now here the curve is already in the form of x equal to 4 minus y square. That means we can move this strip along y. That will be easy. So this will be 0. For finding this point, we just need to equate these 2 points. This is intersection of y x equal to 0, that is y axis, and x equal to 4 minus y square. So what do we need to do first? Equate a, put x equal to 0 in this curve. 0 is equal to 4 minus y square. That means y square is equal to 4, or y is equal to plus or minus 2. Y is equal to plus or minus 2. That means this value will be 2 and this will be minus 2. Right now, y is equal to plus or minus 2. Now we can move this strip in the y direction, that is horizontal strip. Now what we can do is take this strip as dy as we are moving in y direction. Now this will be equal to, area will be equal to, as the curve is symmetrical, instead of calculating between minus 2 to 2, we can just calculate between 0 to 2 and multiply 2 times. This will be 2 times of integral between 0 to 2 y dx, sorry, x dy, that is given by 2 times of integral between 0 to 2, x value is 4 minus y square, 4 minus y square dy. Now we can also do the same problem as finding limit between 0 to 4, that is in x direction, intervals between this 2 times of, and find y dx, change in y value. If we want to find y dx, that will be y square equal to 4 minus x, y is equal to square root of 4 minus x. Again, both will be correct. Answer should remain the same only. Now this is equal to 2 times of, when we integrate 4y minus y cube by 3. Right now, finish. Apply the limits 0 to 2. When you apply lower limit, it will be 0. When we apply upper limit, that will be 2 times of 4 into 2 is 8 minus 2 cube is 8 by 3. 8 by 3. What will be the answer? 8 is common, and this is 1 minus 1 by 3 is 2 by 3. So this is 2 into 8 into 2 by 3. That is nothing but 1632 by 3. 32 by 3 square units. 32 by 3 square units. That is it. Easy questions. Thank you. Arun Kumar says super Anna. Thank you, student. So answer will be, area is 32 by 3 square units. Now we will see the solution. Again, area cut off between x equal to 0 and x equal to 4 minus y square. First we need to know the graph of this. For that, we will substitute x equal to 0 and then solve this. So we will get the y value. After that, we can plot this region. So the points of intersection will be when y is equal to minus 2 and 2, and this vertex is 4, 0. Now the required area is given by integral between minus 2 to 2 x dy, that is f of y dy, and that is integral between minus 2 to 2, x value is 4 minus y square. Okay, as the graph is symmetrical about x-axis, we can write this as 2 times of integral between 0 to 2, 4 minus y square. Answer is 32 by 3 square units. Next is, again find the area cut off between x equal to 0. Again, x equal to 0 means y axis, and the region is, another curve is 2x equal to y square minus 1. It is same as the previous question. Now how to evaluate this integral? Find the area of this using integral. Now first step is to draw the graph. X equal to 0 means that is y axis, and the other one is y axis, and the next curve is, we can write this curve as y square is equal to minus of y square is equal to minus of 2x minus 1. This is minus 2x minus, sorry, it will be 2x plus 1 plus 2x plus 1. We can take 1 to the other side. That means we will get y square is equal to 2x plus 1. We have to make the coefficient as x only. So we need to take 2 outside. This will be 2 times of x plus 1 by 2. Again we can write this as 2 times of x minus of minus 1 by 2. And why do we need to write like this? For finding the vertex of the parabola. As y square equal to x means it is a parabola. So we will get y square is equal to 2 times of x minus minus 1 by 2. Now what are the vertex? Vertex is minus 1 by 2, y is 0. So minus 1 by 2 comma 0 is one vertex. Minus 1 by 2 comma 0 is a vertex. Change the color. Minus 1 by 2 comma 0 is one vertex. Another is, curve will be open, y square equal to x type of parabola. That means it is open rightward. So parabola is like this. So we need to find the area enclosed between these two regions. That is it. So again, for evaluating this, we already have, we can take either y value or x value depending on what we need to do. We already know the x value here, that is between minus 1 by 2 to 0 and y dx. For finding y, we need 2x plus 1 square root. So that means instead of doing square roots, we can directly find the x dy type of area. That means again we have to find this interval, these 2 points of intersection. That means substitute x equal to 0, then y will be plus or minus 1. So that means this point will be plus or minus 1. So that means area is equal to integral of, as this is symmetrical about x-axis, area will be twice of, interval is between 0 to 1 and x dy. That is equal to, x value is 1 by 2 of y square minus 1. So that means 2 times of 1 by 2 of integral between this, integral between 0 to 1 y square minus 1 dx. Now this will get cancelled. dy. Now this is equal to, just use y cube by 3 after integration minus y, limit is between 0 to 1. Okay, I made any mistake. Between 0 to 1 x. This value is actually in the left hand side of that. So answer will be, take the modulus. Yes. As it is x values are negative, we should take the modulus. So even if you forget about using the correct formula taking modulus, when the area comes out to be negative, just apply modulus. Answer should always be positive. That is the key point to remember. So here we will get 1 by 3 minus 1 modulus. That will be 2 by 3. 2 by 3 square units. Finish. So curve is given. First we have to draw the curve. Diagram will be, find the points of intersection between the line x equal to 0 and the curve and draw the curve. Vertex is minus half comma 0 and the curve is open rightward, and then we have to find the area between this region, this shaded region, between this shaded region. that is required area is equal to minus of x dy as x values are negative. So that means we will get solve this two equation and then write x value. X is half of y square minus 1, that is equal to, we can write this as 2 times of, as this is symmetrical about x axis, 2 times of half of y square minus 1, that is y square minus 1, minus is there. So this will be equal to, again change the sign or directly integrate. Answer is 2 by 3 square units. Next question is, find the area between the parabola y is equal to x square and y is equal to 2x. Okay students, we'll stop with this in this session and we'll continue from the next class. Right now, next session we will see the further problems. So thank you. Always keep learning and keep growing students. Success is yours line by line. Endigu endendigu namma tapasya.